Hello everyone and welcome in a new video. And in this video we were studying about machine learning, that what is basically a machine learning. We are seeing a simple intro of ML and what basically ML is, how many types is there, and different things. First of all, we talk about that what is machine learning. What is machine learning? Okay, first of all we understand about what is machine learning. So I start off with a definition of Tom Michael. Tom Michael give the definition of machine learning in 1997. What is the definition? The definition said that he said that what is machine learning? Basically, to learn from experience, to learn from experience with respect to some class of task. Experience with respect to some class of task. With respect to some class of task. And if you want to measure a performance, then there are one more term, performance. The basic meaning that the Tom Michael said is that learn from an experience with respect to some class of task. Learn from an experience, whatever we done, we learn from that, and with the help of that experience, with whatever we learn from that, whatever we learn from the different tasks, whatever we have an experience. So learning from that experience and applying it to a task, that is simply called machine learning. Okay, that is simply called machine learning. This is a little bit tough to understand. So what basically a machine learning in a simple way? So machine learning is basically a branch of artificial intelligence. What is machine learning? First of all, it's an artificial intelligence, AI. AI contain a lot of things. One of that thing is called ML. So this is a simple way to learn machine learning. Okay, so it's simply a branch of AI, or you can say branch of AI or a computer science, which basically focus on the uses of data, and algorithm. Whatever the data we have, in this definition, the data is what? Experience. In this definition, the data is what? Data is experience. Now the more famous definition of machine learning is a branch of artificial intelligence which basically focus on the use of data and algorithm to immediate the way that human learn, and simply improve the accuracy of that thing. If you made a mistake in the past, like suppose an example, if you made a mistake in past, and with that experience, whenever you try to do that work, if you are doing suppose you are doing a work in past, so you form so many, you have when you are doing a work, you get so many errors. Okay, so E1, E2, E3. When you try to do another time, when you try to do the work in a different way, in a different form, not same work, same, we are taking an experience of that work, we are taking the, this is experience, and we are trying to when we are trying to simply make a new thing, what we are doing is we are not making these errors. E1, E2, E3 is not taking place in this time. Why? Because we learn from when we do a work A, suppose that this is work B. Okay, so you are doing a work A, you get an error, you have an error E1, E2, E3. When you do this work, you get these issue. You know that why this issue is occur, so you have an experience to complete a work. So when you are trying to do a similar work, let's suppose B, so you know that what are the possibility of errors that that this work have is E1, E2, E3, but you know that with the help of past experience you are not doing that same error this time. So this is how the machine learning basically works. Machine learn from the past experience. Machine learn from the past experience. Suppose there is a machine M1. Okay, there is a machine M1. Okay, this is a machine M1. Now, if this is a machine M1. Okay, now how the machine basically learn from the past experience. Now we are seeing this thing. You have some data, you have some input. For example, you have some input. Let's take an example that you are making a software that basically detect whether this is in the image car is there or not. In image car is there or not. Simply you are making a software which detect that the car is there or not in an image. Okay, so how this software basically work, how this software learn that how we see that in this image, okay, this is car. So this thing is done by the machine learning. How? Machine you give the input to that machine, the user give the input to that machine. Okay, so what we have in machine learning, we have input. Okay, because we learn from a past experience, so we have an input. We simply told to that software, when you see four tire connected with this shape, or simply a car is a 4 tire only. So when you see that 4 tire in an image which is interconnected, then you detect that it is a car. So simple. We have an input, and with the help of that input we are able to detect a car in an image. So this thing was done by ML. This thing was done by machine learning. Another example, the latest example that most of you are using Instagram. So there's a new feature in an Instagram which simply suggests to you your interest. So this is also an example of a machine learning, because when you are if you are seeing so many reels, if you are seeing reel and simply scroll, so if at a particular reel you spend 5 seconds, and you are not interested in that reel, you spend 1 second, so the algorithm learn from you that this reel where you spend 5 seconds is useful to you, is basically you are interested on that type of content. So after some time the Instagram algorithm gives suggestion of that similar kind of reel. This is what a machine learning work. Machine learning get the data, get the information, get an experience, take an experience and do a particular task of your interest, and do the particular task of your interest. This is what a machine learning is in a simple way. Okay, so this is an example of Instagram. and ML is used everywhere. ML is basically used everywhere. Simply now in WhatsApp there is a new update where you can join so many pages in WhatsApp. Basically, when you go to the story section, you see that there are so many pages. This is also an example of a machine learning. Of your interest, it suggests you that page, and it's up to you that you are joined to that page or not. Okay, so this is also an example of machine learning. Okay, machine learning basically used everywhere. Whenever you see anything, machine learning is basically applied on that thing. Machine learning is applied on that thing. Okay, so this is what machine learning is. Machine learning is used in hospitals, machine learning used in medical field or in engineering, of course. So machine learning is used in everywhere. Okay, how used in medical field? Okay, so you can make a project of that also, that machine learning is used in medical field. For example, you detect with the help of a previous data, with whatever the record of that previous, if a person have a diabetes, take an example, and whatever his previous record is, it told you that, it suggests you that you have a you have this problem or not, this problem or not. Okay, so in medical field, machine learning is used in a very broad way. Okay, it suggests that whether in the pregnancy, take an example, it's when you scan, when you take an input to the software, it suggests that this baby have any issue or not. This is what very in detail in medical field, machine learning is basically used in detail. Okay, so it suggests that take an example, that if you have an input, you have an input, and that software suggests you that this baby have any kind of disease or not. So at that level, machine learning is basically used. Okay, so I hope you understand about the machine learning. Machine learning is basically learned from our experience with respect to some class of task. Or another definition, if you want to learn, you can learn a simple definition which is acceptable at so many places. That what is the definition? The definition is machine learning is a branch of AI. Okay, so ML is a branch of AI. AI is what? AI is artificial intelligence. Machine learning is not AI is not a part of a machine learning. Okay, remember this thing. AI is a broad concept. Machine learning is simply a category of AI. AI have a numerous category. Machine learning is one of them. Okay, machine learning is one of them. So machine learning is what? Machine learning is a branch of artificial intelligence, or you can say artificial intelligence and computer science, which focus on the use of data, which focus on the use of data and focus on the data and algorithm to imitate the way that human learn. Okay, simply that imitate the way that human learn. Basically, why we are using machine learning? To easy our life, simple way. Okay, to easy our life. So that's why we are using machine learning. And machine learning is simply a branch of AI or computer science which focus on the use of data and algorithm. Now machine learning is not only this. Machine learning is not only suggesting your interest. With the help of experience, it do some task. With the main common thing in machine learning is you have an input. You know what his input is. Now further, machine learning is classified into 3 types. What are these types? So okay, so I hope you understand about this definition. You first of all simply recall these things, then we are moving towards the types of machine learning, because in this we learn about when we have an experience, we have an input. Now what happen, we know about the input, whatever the input it is, we know about that, and we also know about the output. If we take the example of this car example, we know that 4 tire is basically a car, and we detect that and we know the output that in this image if there is a 4 tire, then yes, it is a car. So when we have an input, when we have an output, then what kind of ML is this? So we see that thing. When we have only input, then what kind of thing we call that? So machine learning is categorized in numerous way. Okay, it is basically categorized in a different part. So you first of all simply recall this thing, that what is ML and this definition, then we are moving towards the next thing. Okay. Okay, so now we are moving towards the next thing in machine learning. Now we are categorize this machine learning. Okay, so now we discuss about ML. Now what are the categories of ML, and what are the different things that we need to learn in this? So the first thing is supervised learning. First of all, we need to know about supervised learning, that what is supervised learning. Okay, so in supervised learning, if I told you in a simple way, so in supervised learning you know about an input and you know about an output. we learn an input and output map. We learn from an experience that okay, this is that thing, this is that thing. We learn from an experience and map the output, and we map the output. Okay, so this is what supervised learning is. Most of the time, okay, in ML you need to know about that thing also. You know about an input. Wait a second. Okay, so you know about an input and you know about an output. If you know both of them, you know that okay, this is what an input is. We provide that input to the machine. We provide input to machine. This is machine ML M, and we suppose that this is the output. For example, we're talking about that car. We say that okay, this 4 tire is, then it's a car. Your software basically process that car. Your software is basically process that car, and you know about an output that okay, if 4 tire is there, then this is what a car is. But so many times, what you think about that output is not provided by the software. Means whatever you predict is not correct. Okay, so you get another output. You get some else output by the software. You predict this output, but you get this one. So many times, whatever you think is not successfully do. Okay, so this thing you need to remember, that output is similar to what you predict, but not same that what you predict basically. Okay, so this is what happened in the software also, so that whenever you see that okay, this is not an output, but output is similar to what you predict, is also come in this category. Okay, so supervised learning, you learn from an input and you map, and your software basically map an output. That output is equal to your prediction or not. That's what the software basically work like that. Okay, now the supervised learning is basically of 2 types. Supervised learning is of 2 types. First one is classification. In classification, in a simple way, if we talk about in simple way, it's a categorical output. Categorical output means whatever you think about that output is that, you know, output is of different categories. Output is of different categories, what you predict, what basically output occur, and so many things. So it's basically a categorical output. It's also of different types. If that output contain an error or not, in that basis, this is of this classification is categorical. Okay, and the second is regression. Now what basically regression is, it's when the classification is done, you have a numerous output. Categorical means what? Categorical means there are so many categories of that output. Okay, but when you apply regression, you get a continuous output, you get a fixed output, you get a continuous output. This is what a classification and regression in short term. We see this thing in detail, but for an instance, it's simply a categorical output. Classification is a categorical output and regression is a continuous output. When you apply classification, you get a numerous output. When you apply regression, you have a fixed particular output. Okay, we see this thing. Now the second This is a basic introduction of ML. What is basically ML? We're seeing this thing in detail. What is classification? What is regression? Regression is of different type. Classification is of different type. We see that thing in detail. Okay. Now the first one is supervised learning, and the second part of ML paradigms is unsupervised learning. Unsupervised learning. Unsupervised learning. Okay. So we know about supervised learning, that what is basically a supervised learning. Now we talk about unsupervised learning. So by this, you know that remember one thing, that in ML input is there. Input is there because without having an experience you cannot predict the output. So every time in ML input is there. In supervised you map an output. In unsupervised, what basically software do is, software simply discover the pattern in the data. It discover the pattern in the given data. It discover the pattern in a given data. What basically do it? Discover patterns in the data. Discover pattern in the data. This is what unsupervised learning is. In a simple way, whatever your data is, simply discover some patterns on that and predict the output, predict the result. Simple example like weather forecasting. It discover the pattern. Okay, for example, in March to March to May, it's what weather it is. From May, June, July, what weather it is, very hot, very cold, what weather it is. From November to February, a cold weather is this, what kind of weather it is. So simply from a particular period it discovers some pattern and predict the result. For example, if someone asks what is the weather in the December month, so it discover the pattern from a previous year, because in ML you have an input. Okay, so there is no need to worry about an input. In ML you have an input. You take something from an input, whether you learn input, whether you discover some pattern on that, it's up to you. If you discover pattern, it simply is unsupervised. If you take whole as an input and with the help of that whole you predict output, it's simply a supervised learning. Okay, so the discover pattern on that data. So it discovers that in previous year what the weather in December, in more previous year what basically the what weather is this in the month of December. So if it is cold, then it predict that in December month there is a cold weather. So it predict by discovering some patterns in the data. Simple. This is one example. There are so many examples of unsupervised learning. We see that thing when we seeing unsupervised learning in detail, but in basic way. This is also in detail basically, but in basic way, what is unsupervised learning? Discover the pattern in the data. It is also of two types. Now what are these two types? First one is clustering. Or in clustering, groups were formed, cohesive groups were formed. In clustering, groups were formed, or you can say cohesive grouping. Means at a particular group. For example, this is what we have data, plus minus. There are some positive signs here, there are some negative signs here, but we take an ideal condition where in this side every sign is plus, and here every sign is negative. So here you can say that it form Here you can see that positive group, negative group, positive group, negative group. So we simply make the group. This is what clustering basically. When we see this in detail, then we are seeing that what is clustering, what is association. So we this seeing this thing in detail. Okay, so this is what a clustering is in a basic way, that it form a particular group. This is an ideal condition, a normal in a practical way, in a normal way. In a general way, if this is positive, some negative is also there, some positive, some negative, positive, here negative, negative, positive, negative, positive. So this is what basically in a general way. But in ideal condition, this is what, yes, when we see about bias and variance, we seeing this thing in detail, that if this type of thing is there, when we draw particular line, so when we draw a particular line, so it's simply in ideal condition. When we draw a particular line, remember that in machine learning your given data is simply distributed by a straight line, y is equal to mx plus c, y is equal to mx plus c. In the general way, okay, in general way it's difficult to make a groups, but in ideal condition, positive, negative, here you can see that all positive signs, here you can see that all negative signs. So you simply distribute, you make a group. This is what clustering is basically. Okay, remember that we are distributing this with the help of a straight line. Everything this is also by a straight line. When we know about a regression, linear regression and logistic, then we see this thing in detail, that how we distribute this thing. In ideal condition, it is easy to make a line, and distribute it. But in a general way, how you can distribute this, how you can apply regression. Okay, so we seeing the thing in detail. Now we talk about the unsupervised learning. So it just cover some pattern in the data, and it is of two type: clustering, which is a cohesive grouping, and association. And then association. Now, what is association? Association is a frequently occurrence. Cohesive means at a particular grouping, this group is formed, this group is formed. So if positive, when we say about positive, so we see only this side. When we say about the negative, we see on this side. If we talk about again positive, then they are not frequently formed. Positive at a particular place, at a particular in a group, and negative in a group, they are not frequently moving like this. In this example, they all are frequently moving. Okay, so association is a what? Frequent occurrence. Frequent, QU, frequent occurrence, like this. Okay, so we see these things, but in a simple way, supervised learning, we have an input, we map an output. In unsupervised learning, discover some pattern in a data and form an output. We predict that output. Now there is one more thing which is called reinforcement learning. Okay, now the third one is reinforcement learning. It is what? Reinforcement learning. Now what is basically a reinforcement learning? Okay, what is basically a reinforcement learning? We learn some new controls. We learn control. Reinforcement learning is what? Reinforcement learning is basically we learn the control. Whatever thing we don't know, we learn that thing and make. For example, first time when you are try to ride a bicycle, you don't know about that how to ride a bicycle. First time when you are doing this is a new thing to you. So this is an example of reinforcement learning. When you are playing chess, okay, driving a bicycle, playing chess. So these are the example of reinforcement learning. You learn a new thing. Reinforcement learning is what? You learn a new thing from the environment. This is also an important thing. In a general way, whatever you learn from an environment without damaging an environment, or with the help of an environment, you simply it's reinforcement learning without damaging an environment. Okay, there are so many questions which offer reinforcement learning. If you are given an NPTEL of machine learning, then you know about reinforcement learning. Then you see there are so many reinforcement learning questions. So that thing is, if it is not affect the environment, then it's simply good for us. If it affect, then it's not an reinforcement learning. Driving a bicycle not affect an environment, you learn and you learn new control, it's reinforcement learning. Playing chess not affect the environment, it's a basic difference. If you ask a question, if affect environment, then of course it's not an reinforcement learning. Okay, this is what playing a chess, you learn a new skill, new control. This is also an example of reinforcement learning. So I hope you understand about the reinforcement learning and supervised learning, unsupervised learning, reinforcement learning. Okay, so this is what is, you can simply analyze for in a few minutes, then we are moving towards the next type of thing, that what are the tasks that machine will do. Machine will do numerous tasks, so we see that task. Now for an instance, you simply revise this thing, simply recall this thing. So this is machine learning paradigms or types of machine learning. What is supervised learning, unsupervised learning, reinforcement. Okay, so we see this thing in detail, but this is what a basic overview of that thing. Okay, we see about classification, regression, and different things. Okay, so now what are the tasks that machine learning do? So now we see about machine learning tasks. Machine learning task. Okay, so machine learning provide numerous tasks. We see the in this example. Okay, so what are the tasks? That clustering, association, classification, regression. So these are the tasks that machine learning perform. We see that how it perform and what are the output. We see questions on that. So these are basically the tasks, machine learning tasks. Okay, so task and what basically that task measure. What basically that task measure. So for example, we say about supervised learning. In supervised learning we have classification. We have classification. So what basically the classification measure? Classification measure an error. What classification measure? In supervised learning, here in supervised learning, classification is categorical output, regression is continuous output. So what basically the classification measure? Classification measure an error. Classification measure an error. Now the second thing is what? Regression. Regression. Classification measure error. It's of supervised learning. Regression is also supervised learning. In classification, the output is categorical. So and regression, it is a continuous output. So output is there. So in this case also, the regression is also measuring an error. In this case, it's also measuring an error. Classification is also measuring an error. Okay, regression and classification both measure an error. After that, what are the tasks that ML perform? ML perform clustering, which is an unsupervised learning. Clustering. Now what clustering measure? Clustering measure the purity. Purity. Clustering measure the purity. I simply show you an example where this is a positive, negative, one group, two group distributed by a straight line. So this is what a clustering is. So it measure the purity. It measure the purity means that this is a particular type of group. Above that line, above that straight line, the particular type of group. Below that straight line, a particular type of group. So the clustering basically measure the purity of that group. Okay. After clustering, we have association. Associations. Now what basically association does? Association basically support or give a confidence or simply support. It support or given confidence. Association is okay. And unsupervised learning, association is what? Frequent occurrence. It's not a fix in it. If we make in clustering, we make a group, so it's fixed that okay, this particular group, this particular group. So it's define the purity of a one, this only positive, negative. But in association, positive, negative, it is distributed. Okay, so frequently occurrence is there in associations. That's why it support both. It support both. And the last thing that ML measure is reinforcement learning. It's reinforcement learning is not having subcategories. So the task that ML perform is reinforcement learning. Reinforcement learning. And reinforcement learning basically related to cost or reward. It basically measure the cost or measure the reward. If you learn some control, so it's good for that or not. So simply it reward or cost symbol, both of them are same thing. So this is a machine learning task. These are the tasks that machine learning perform: classification, regression, and we see this thing in detail, that what basically classification is, regression is. So we see that thing in detail. But for now, it measure an error. Okay. Regression measure an error, clustering measure the priority, association measure the support and enforcement cost. Now there is one more thing, that what are the challenges when you are doing ML, then what are the challenges occur? What are the different kind of challenges that occur when you are using ML, when you are making a software, taking an input, there produce an output. Okay, so what are the challenges basically occur? Now we discuss about the challenges. So, and we see those challenges in video. We see that how we solve that challenge. Okay, so what are the challenges? How good is the model? How good is model? You made a software, then how good that software is, how good that model is able to solve that problem or not. So how good, how accurate, how efficient it is. So this is the challenge that occur when you are using ML. Okay, we take an example of that Instagram. If a person spend 5 to 10 seconds at a particular post, so it's of that interest, if that person interest, so how at that same related post, that related content, that post, so how you are simply differentiate that content, that okay, that type of content is perfect for that person, that kind of content is perfect for that person. How you differentiate, and how you implement to that thing, to that algorithm in a model. So these are the challenges, and if you solve that challenge, you make a very perfect model. So the challenge, and the main challenge is how good is model. Second, how do I choose a model? How do I choose a model? This is also a challenge which occur when you are doing ML, when you implement machine learning. So that if you have a model, how do I choose that which model is perfect for that kind of work, which model is perfect? So this is also the challenge which occur, that how do I choose a model, because everything is categorized in a various in a different thing and a different ways. Okay, so it's difficult to choose a particular model. This is also a challenge which occur. Third thing, this is also a very important challenge which occur is, do I have enough data? Do I have enough data? This is also a challenge which occur. Do I have enough data? That whatever data we have, with the help of that data, with the help of that input, we are able to produce that output or not, we are making that output what the user demand or not. So this is also a challenge which occur. Do I have enough data or not? Now the fourth challenge we have is, we know, okay, we have a data, so that data is of that quality or not, that data is able to get that kind of output or not. So this is also a challenge. If we are not having enough data, output is not there. When we have data, that data is of quality or not, that data is basically help that machine to produce that output or not. So this is also an important thing, that do we have an quality data, do we have a quality sufficient quality of that data. Okay, so is the data of sufficient quality? that data have some sufficient quality means that data have an error or not. Okay, so the data, errors in the data, you can write it like that, errors in the data. Or you have so many data, like you have a data with the integer values like 20, 30, 40, 50. So there is an error in the data or not. If there is a particular value is not correct, or that means the error in the data means. Okay, and if you have a data like 20, 30, 40, 50, 90. Okay, so error in data means that 90 is error. If you are implement 90 to a particular task, that if you are that this data, this input is given to that software, and that software not able to produce a particular output, so this is also this what an error in a data is. And the second thing is missing values. Second thing is missing value. Second thing is missing value. For example, after 50 we need 60, but we have what, 90, so 60 is missing. So this is what data is not of that quality. Okay, so these are the simply examples of data sufficient quality of marks. And there are so many things. Okay, there are so many challenges which occur when you are solving this, when you are simply solving a data is of so many types: trained data and untrained data. Okay, so now whatever we learn, simply these are the challenges, these are the machine learning tasks, these are the reinforcement learning, these are the ML paradigms. This is what ML is. Okay, so now we are doing some questions related to that. What basically we learned, we are doing some question related to that. We are doing some questions. Okay, so the question is, which of the following is supervised learning problem? You need to answer that. Which of the following is a supervised learning problem? You need to answer that. I simply give you an option: A, B, C, D. Question number 1. Okay, you need to listen the question very carefully. The question is, grouping related document for an unannotated crop. Grouping, remember every word. When you are solving a ML problems, you need to see every word, what that word means. Okay, it says that grouping related document of an unannotated group. So grouping is there. So grouping is come in an unsupervised learning. Grouping is occur in an unsupervised learning. Here we have cohesive grouping. Okay, so you need to see that thing. Okay, you need to see and answer that question. The option number A is grouping related document from an unannotated corpus. The second option number B, predicting credit approval based on historical data. The option number C is predicting credit score, predicting the credit approved based on historical data. Predict, remember this, what basically the option says, that predicting credit approval based on historical data. C option, predicting if a new image has cat or dog. What you want to predict? That image, the new image have cat or dog. Predicting if a new image has cat or dog based on the historical data, based on the data we have of other image of cat and dog. We have two images, one is an input and one is an output. Input image, output image. With the help of input image, it is easy to determine okay, what is cat and what is dog. Okay, cat and dog, we are easily determine that thing. But in new image, how we are determining that okay, this is cat, this is dog? So we read this input, we know okay, so this circle, the dark circle means cat, the only circle means dog. Okay, for an example, so by an input, by an historical data, we the software basically learn okay, this is cat, this is dog, and in new image it easily predict that thing. So with the help of historical data, it easily predicts in a new image that it is cat or not. Okay, so third option is predicting if an image has cat or dog based on the historical data of other image of cat and dog, where you are supplied the information about the image is cat and dog. Simple thing, what basically I explain you here is the option number C, cat and dog. Cat and dog, you are predicting that which is cat and which is dog. Okay, option number C. Option number D. Option number D is what? Option number D is fingerprint recognition of a particular person. This is related to a fingerprint. Fingerprint related to question. Okay, fingerprint. So option C is fingerprint recognition of a particular person used in biometric attendance, from the fingerprint data of a various other people and that particular person. Means for an attendance in a class, suppose an example, in a class this is taking an attendance by a fingerprint. So this is what thumb impression, you need to place a thumb impression and you mark as present. So with the help of historical data, with the help of that particular software know about your fingerprint, know about your biometric. So with the help of that biometric, it is able to attend you present. With the help of historical data, the software mark you present. So this is of supervised learning or not. So these are the option. Option number A is of grouping. Okay, so first of all, I told you about the supervised learning is what? Supervised learning, we have an input and we predict an output. With the help of input, we learn from an input and predict an output. In unsupervised learning, we discover some patterns. In reinforcement, we learn some new control. Now you need to choose the which is correct. Now this is not a multiple choice question, it's a multiple selective question. So more than one option is correct in this case. It's a multiple selective question, more than one option is correct. So this is what the question is look like. You have a 1 minute to solve this question, then I told you the answer. Now you have solved this question. Okay, so now the correct answers are, first of all, option number A is not correct because it is related to group and a group is formed in an unsupervised learning. Now we see the option number 2. Okay, so option number 2 says predicting credit approval based on an historical data. If we have an input, we have an historical data, we have an input, we have an experience, whatever you say, we have an input. With the help of that historical data, with the help of that input, we are able to predict the credit score or not. So this is what a credit company basically do. This is what the new apps would do. They are simply gives you credit and give you a credit score with the help of what? With the help of your previous data, how much transaction you do, how much different thing you do. So with the help of your historical data, with the help of your input, it is easily predict the output. With the help of that historical data of that person, it is easily predict the credit score. So this is what a supervised learning is. We have an input, and with the help of that input, it predict the output, it map the output. So yes, option number B is correct. Option number B is correct. Okay, option number B is correct. Now we talk about option number C. Cat and dog. Now okay, so option number C is what? Predicting if a new image has cat or dog. This is new image or output image. So the new image have cat or dog. We need to predict that with the help of historical data, with the help of image, with the help of another image in which we already predict that okay, the dark one is cat and the bright one is dog. So software know about that image, about that eye image. Okay, so this is cat, this is dog. With the help of that thing, it is easily predict the output in a new image. Okay, so the dark circle is what? Okay, so that circle is what? Cat. We know that because in a previous image, in an historical data, the dark circle is cat. So with the help of previous data, it is easily predict that with the help of previous data, it means with the help of the previous data eye image, it know about the cat, it know about the dog. So with the help of that, it is easily predict that thing in an output image also. So yes, this is what supervised learning is. With the help of an input, with the help of an historical data, it easily predict that output, it map that output. So yes, option number C is what? Correct answer. Option number C is also a correct option. Now option number D. Option number D says fingerprint recognition of a particular person used in biometric attendance from the fingerprint data of a various other people at a particular person. With the help of previous data, with the help of that fingerprint, with the help of that biometric, we have an input, biometric as an input. With the help of that biometric, we are able to make present or not. In a fingerprint scanner, in a fingerprint recognition, if you put that biometric, yes, it allow present, it make present, it attend that thing. So yes, when we have an input, we can easily map an output. So yes, this is also part of this is also an example of a supervised learning. So option number C is also a example of supervised learning. So I hope you understand about this thing, that how you distinguish grouping, how you distinguish supervised learning. Whenever you have an input, simple input, or question says that historical data, and it says that experience. Whenever you have this thing as an input, when you know that thing, you can easily predict, and you can easily predict output also. You map that output. So yes, this is an example of a supervised learning. This is an example of a supervised learning. Remember that grouping is not allowed, grouping is not there. Okay, so whenever you see grouping, it's not. Grouping is an example of unsupervised learning. Okay, so this is what the question is. I hope you simply understand this question. Now we are moving to the question number 2. Question 2 says what? Which of the following are classification problem? Remember that classification is an example of a supervised learning. In classification, grouping were formed. Okay, so now see what are the options. So option number A, you need to find the classification. Now this question is come in detail of supervised learning. This is a part of a classification, is what a part of supervised learning. So now this question goes in detail to the supervised learning. Okay, so that's why for example, if you are giving an NPTEL of machine learning, you see these type of question, because in that thing every question is basically wants to know about your concept, knows about your in detail concept. Now option number A, predict the run a cricketer will score in a particular match. You need to predict a run. You need to predict the run of a particular cricketer in a match. Option number B. Classification, categorical output. Classification and regression both are the different thing. Now question is, predict the run a cricketer will score in a particular match. You need to predict a run what cricketer will score in a particular match. Option number second, predict which team will win the tournament. Predict which team will win the tournament. Option number C, predict whether it will rain today. Predict whether it will rain today. Option number D, predict your mood today. Predict your mood today. So these are the questions. Remember that classification means categorical output. Your output is not particular, your output is different. Now option number A says that predict the run a cricketer will score in a particular match. Option number B, predict which team will win the tournament. Predict whether it will rain today or not. Predict your mood tomorrow. Remember, it is a part of a classification, it's a supervised learning. In supervised learning, we have an input and we map an output. Remember, we need an input. Now you have 1 minute to solve this question, then we are solving this question. So I hope you select the correct option. Okay, this is a multiple selective question, so more than one option is there. Correct answer. Option number A, predict the run a cricketer will score in a particular match. In this case, there is no input and classification is of supervised learning. If we not have any input, we cannot predict the output. For example, in a previous match, it scores 0 run. The previous match that cricketer played, it scored 0, and previous match it scored 19, 20, 21. So we cannot predict that how many runs that cricketer will made. So we cannot predict that thing. So this is why this is not a classification. This is not a classification problem. Option number B, predict which team will win the tournament. Predict which team will win the tournament. For example, if we have three teams, A, B, C. We have three teams. We know about that data that A is a team which wins frequently. B also win the tournament, C also win the, A also win the tournament, but A is a team which win the tournament very frequently. So you can able to predict that which team will win the tournament. So yes, we can predict that thing with the help of the input. So we can able to predict. But if you are predicting something, then of course you have an input. If you are predicting something, of course you have an input. Remember this thing. If you are predicting anything, input is also there. If you are predict, yes, it is a part of a classification learning. So this is a trick. So with the help of the trick, these three options are correct. Now if this predict is not there, then also you need to simply see that if there is an input, yes, that also a part of a classification. Supervised learning, and supervised learning and classification is basically a category of a supervised learning. So yes, we can predict which team will win the tournament. Option number C says that predict whether it will rain today or not. So yes, we can predict that it will rain or not with the help of previous data. We can able to predict that okay, so today is rain or not, and tomorrow, previous day what kind of weather it is, in previous day what kind of weather it is. So with the help of that thing, we can able to predict that it will rain today or not. Option number D said predict your mood today. So what kind of mood your today is, it also depend on the previous day. So in previous day what kind of mood you have, previous day what kind of mood you have. So with the help of that input, with the help of that historical data, yes, we can predict what's your mood today. So yes, these three are the example of a classification learning. And classification is more categorized. Classification means categorical output. You cannot have an one output, you cannot have an one particular output, you have a categorical output. So if you are predicting which team will win the tournament, yes, we can predict with the help of that, okay, A is frequently win the tournament, so A maybe win the, we can predict that thing. But classification, the question says that classification, these are the example of supervised learning, but it is a part of a classification. If this problem is a part of a classification or not, in this we can predict that A is win, but we can predict that A is win, but B can also win, C can also win. So we not having a one fixed output. So that, and in classification, what I basically told you in classification, that we have an categorical output. We not having a one output, we have a different output. In regression we have a continuous output, means in regression we have a one output, but in classification we not have an one output, we have a different outputs. Okay, so this option is correct because A, B, C, these three options are there. Output is categorical. Whether it will rain today, yes or no, yes or no, it is also categorical output. Yes, it's also problem of classification. Option number C, your mood, what your mood today, angry, smooth, or what kind of mood basically you have. So this thing also, there is also a numerous category. Okay, these are not a fixed output. Okay, so your mood is angry mood, so there is not fixed output, your output is categorical, but yes, you have an output. So that's why it's in supervised learning and categorical problem. So these are the questions. So I hope you understand these concepts and these questions. These are the basic introduction of ML, what is ML and what is supervised and unsupervised. Okay, so this is what a basic introduction. Thanks for watching this video. Like, share and subscribe my channel.